Hello, my name is Felix Schaller. I'm from the Seed SME partner in HUBCAP, the company Validas AG. We are providing experiment for the proof of concept of the HUBCAP platform that we perform tool qualification for tools in the HUBCAP environment. In our experiment, we are performing this tool qualification on the tool Autofocus Felix, which provides a use case of domain-specific design space exploration. And we gonna qualify this design space exploration for functional safety domains. Therefore, I just prepared for you a little presentation how ToolChain qualification for safety standards are working. So we design a process from our standards documents, and we formalize this process, and therefore we have we can generate certain artifacts like compliance reports and a verification and validation plan, and also the entire process description. This is a very abstract overview of the safety plan. The more practical part, what is more related to our experiment in the HUBCAP research project, is the ToolChain Analyzing and ToolChain Qualification, which is more covering this part in the upper right. And these other processes are more in the theoretical and the full definition safety case. So therefore, performing on the HUBCAP platform is our ToolChain Analyzer, which has a model about which has a model of the autofocus software. So we create a reference process or a reference model of the autofocus software, where we describe features of the software, functionalities in features, as you can say, and we assign potential errors to these features. So let's say input-output module is creating writing errors on the disk, then you just assume this as a potential error, and by creating a failure model error analysis, you provide evidence if this error is a potential threat. Will it really occur, or is this just a hypothesis? Or we start with a hypothesis, and then we are leading this hypothesis to a real evidence if this error is existing or not in the toolchain. And therefore, we have a model that contains mitigations and potential errors, and those mitigations mitigate some errors, but the remaining unmitigated errors that will be finally qualified in a qualification kit, which provides evidence via unit testing that those threats are not existent in the software. When executing this qualification kit with a testing automation unit in the background, we are running tests automatically, and when these tests are finished, we create comprehensive documents which explicitly describe all the features, the occurrences inside the tests, and also the connections to mitigations, and actually the entire toolchain context that this tool is interacting with. So qualifications are always context related, so we always need a context in which the tool is operating to really create a tool confidence level. So the tool confidence level then decides over the measures, the means that you have to um, apply, or you have to follow to receive a fully coverage of a functional safety in the functional safety environment. So therefore, we are performing this QKit in our HUBCAP environment. So we have here, this is kind of wizard tool that is performing that QKit. When we open this tool, we are guided to a dialog that wants us to pick a basic or root directory where we are going to put all the qualification documents inside. So I pick the environment for our HUBCAP platform, our output folder that is finally holding all the qualification results inside. So here I already created one qualification run, and I just create another one. All right, we choose this folder, and then we click on next, as you are used it with other wizard tools. We want to qualify this feature of autofocus. We'll talk about this in the next slides. For the standard ISO 262 and with the highest safety level SLD. So here is our tools are listed, which we want to qualify, and we have usually several use cases which we can qualify in such a model. So we just need, for instance, for this environment, we need this use case, design space exploration, and other use cases like model-based system development is not required for this environment. That's why I would not need to qualify other use cases except the ones I really need for this environment, and therefore I just leave it as it is now presetted, that I just click on this use case. Just to add for this HUBCAP demonstrator, we, as it is a demonstrator and works as an example for other qualifications, we cannot entirely qualify this use case because I just included these other use cases that you can see how it would look like in other environments, and as an example, that you can just have a good look and feel how it will look like in other real applications at the end. So this is the one that is applied in our experiment, seed SME experiment, and this is therefore modeled completely. So the next we wanted to clarify what kind of software version we are qualifying, and therefore we pick our most current version of the autofocus we have installed, and also we rely on, or we refer on known bugs, known bug manuals that we are managing, so that we see known bugs are managed in on the website, and that this is important information for our safety documents at the end, that it is known, so that we have a snapshot of the current known bugs that are recorded, and therefore they will be included inside the safety documents as a reference, to know where this which status of the known bugs are given, and therefore are restricted for use. This thing is, we select the features we want to qualify, and as I already mentioned, there are not all features qualifiable. As you can see it under color coding below here, red color coding means unusual feature. This means that this feature cannot be qualified because there are no either no mitigations, or there and also no given tests for it. So you need at least testable features or mitigatable features, but unusual features, they have either tests or either no mitigations, and if they have none of them, they cannot be qualified. So, but because we are, for this use case, we have only mitigatable, or in this case testable features. That's why we are able to continue here. Otherwise, this button at this point would be grayed out, and you could not continue further, because your set of qualifiable features contain unusual features, and as long as they are unusable features inside your sets, then you cannot continue from this point. All right, next is the mitigations we want to select for this use case, and I already pre-selected in this model the required mitigations that are given for this use case. And as long as this part is empty, then you do not you have everything set up. But if I, for instance, deselect this, then we have an uncovered error that is showing up here, and this uncovered error restricts us from continuing our qualification process. So that means that I require this type of mitigation, and then I can continue with my qualification process. All right. Next, we provide information about the qualification process, the project itself, that provides all the information that is then later generated in the documents, which are required to be included in the documents, like who is the qualifier, who is the tool user, when the qualification and the planning phase happened, and finally where all the artifacts are stored. So these are references for all the artifacts, and this information will be later stored in the qualification documents. All right. Also here you see this is grayed out because we require a name of qualifier and also a tool user. After that, and also we set the dates for this. So we just I just use the current date and for this demonstration. So we then can be guided further. So next we are designing or we defining the qualification environment. Already preset for us is a word editing software that is then finally finalizing the documents, and we need also Graphris that is pre-installed in this tool environment. This Graphis is required to create all the diagrams that are then included in the safety documents we generate at the end. So this is these are mandatory paths you can use in the Linux environment. We have a substitute for Windows Word that is LibreOffice, and LibreOffice offers almost all the features that we know from Windows Word, except some macro specific issue. I relate to this later in the process of the demonstration of this qualification. All right. So we have when we have set up these mandatory tools, we can then go further to our other informations. What you shouldn't touch is those values below here, because they are required to be at this value as they are set up here. Otherwise, you will break the qualification process. For the execution of the qualification and the unit tests, we test automation unit that is running on Python, and therefore you require to provide the path to the Python program. And it's also required that it has to be a Python greater version 3.6, which means 3.7 or 3.8. In this tool environment, in this HUBCAP tool, Python 3.8 is installed and also symlinked to the Python executable. Or just when you call user bin Python, then you will be automatically guided to 3.8 Python version. I'm not demonstrating this. You can just check it for yourself if you like. And then our qualification target, which means the program that we want to qualify, is this program, which is the Autofocus Autofocus 3-Phoenix. And because all the tools are pre-installed in this tool environment, we do not really need to adjust these values because they are already set up for you. But you have the opportunity to link these values to other Pythons or to other autofocus programs you want to qualify. All right, next page. It's a you can, if you already if not all qualification kits have automatic tests, there it's also required in some safety procedure that you perform manual tests, and those manual tests can be exported first in a list like a checklist, and then you re-import this kind of checklist again into the model. And if all these tests are passed, then you set them to pass, and then these manual tests will be entered in the model. So the qualification support tool knows what mandatory manual tests have been performed and if they are successful or not. And finally, and this is also if you already performed tests, automatic tests, then you also could import these automatic tests, these JUnit test reports with this feature, with this function. All right, next is just the location of our qualification documents templates. So the templates we are using to generate headers, footers, and content tables and all others modules inside our reports, that we have a certain template design that is used to create the final documents. And so we can check if we want to generate all these documents, yes or no, and so on. On the next page, we then finally get an overview, a summary of the qualification process and especially the automated tests we are performing. And now the setup with this wizard tool, with this qualification support tool is finished. We then click on finish, and then we generate our documents. So first, the static documents which are not reliable on the test execution results get generated first. This is the tool qualification report and the tool safety manual. So these are independent from the test results and just give a comprehensive overview of the tool chain or the features that are described in the safety case and all the other required information to know in advance how this tool is going to be qualified and what features are existing and which one is critical or not, and many other informations that are inside. Safety manual as well, which use case is qualified and what is allowed or restricted in this use case. So now we are having our report generation finished, and automatically the LibreOffice application is started. Then you will receive this kind of little error message. Just ignore these error messages that are just Windows Word specific commands that are not supported by LibreOffice. And then after you ignored all these messages, then you have this tool, the LibreOffice open up, and then it shows you the toolchain classification report. And this classification report, this is something that is independent from the test result, as I already mentioned. And it offers you overview of all the features and the relation to the functional safety for this tool. As I mentioned, not all functions from Windows Word is supported by LibreOffice or not compatible. Therefore, you need to do some manual adjustment that you need to update those fields. Most of those fields are filled out. You see them as grayed out, and you see that they already introduced the dates and all the other fields that are related to this model. And then you can see that this document has a comprehensive size of 69 pages. So on these 69 pages, you will see all the relevant information that is required for the classification of this tool, as which confidence level it has, and the relation to those features. And then you see these features laid out in some information boxes, how they are interact with each other. And by that, you see what is relating to each other and how it needs to be qualified, and therefore gives you a little overview of the architecture and the safety case that is dealt with this architecture. And yeah, it helps you to understand the whole situation better, and therefore we included also these diagrams of the safety case. Right, when we are now close this document, then say save, because we are updated all the information. Yes, we used the old. Okay. Then we'll continue with other documents. Here is the same, and then just makes minor adjustments that since you update the index of the safety the tool qualification plan, and this tool qualification plan is then showing you how we are performing the test strategy and the test itself and the qualification project and so on. So these documents are created in advance to the unit test. When we are finished with reviewing these documents, or just roughly reviewing and updating all the indices and content tables, then you can save and close this, use Word format, and then finally the QKit starts to copy all the required artifacts that are required for performing the automatic unit test into our qualification folder, and the root folder in which we want to perform, which have all the artifacts that are required for the automatic testing. And when this copying is finished, then automatically the test automation unit will start to operate. So now it's already starting and performing the first test by opening up the Autofocus tool and calling the first test. And the test consists out of, as you could see, 84 test modules. Sorry, one test module and 84 unit tests. And it will take now a while until all these unit tests are performed, and then finally we will receive a report on the success of this unit test or not. The whole procedure is just looking quite similar to the ones we have already seen. So the end, the tool is printing a log of the import and the execution of those tests, and then import everything in the final documents that are again generated the same way as the documents we already created before the unit tests have been started. So just with a slightly different content that is then related to the execution result, and containing the information if all potential errors are covered with successful unit tests or not. And if they are covered with successful unit tests, then the document will contain the phrase successfully qualified. And we are done with our qualification, and now can finalize these documents in a final review process in the verification and validation before it's getting handed over to the certification institutes like the German Technical Instruction, it's the TÜV actually, German TÜV, which is certifying technical installations and also software in a functional safety document. All right, thank you for watching, and I hope you enjoy this ToolChain qualification by yourself, or try it out by yourself and see how it works. And I wish you much fun with it.